Hello everyone. Once again, I welcome you to the video lecture on first part of the first module, that is conduction and breakdown in gases. In last video, you have studied about collision process in gases. So in this video, let us study ionization process in gases. Ionization process will takes place after the collision itself. So once the collision it takes place, so then ionization process comes into picture. What do you mean by the ionization process? Ionization is the process by which an atom or a molecule acquires a negative or positive charge by gaining or losing electrons, often in conjunction with other chemical changes. So this is a water ionization process. That is, once the charged particle collide with atom or molecules, either during this collision, either the atom or molecule acquires a negative charge or a positive charge by gaining or losing an electron. So this is called as what? The ionization process. So whatever be the resulting electrically charged atom or molecule, so that is called as what? Ion. If the atom or molecule during collision, they may what? Lose an electron, or they may gain an electron, or they may become what? Negative charge, or they may become what? Positive charge. So that resulting electrical charged atom or molecule, so that is called as what? The ion. A gas in its normal state is almost a water perfect insulator. So this you studied in water the first video. So that is water, gas as in water, the insulating medium. However, when a high voltage is applied between the two electrodes immersed in a gaseous medium, the gas becomes a conductor and an electrical breakdown occurs. So obviously this also you discussed in what? The breakdown mechanism. So once the high voltage is applied between the two electrodes which is immersed in a water gas as a water medium, in that case the gas becomes a water conductor and an electrical breakdown water occurs. The process that are primarily responsible for the breakdown of gas are ionization by collision, photoionization, and the secondary ionization process. So whatever be the process, so that is the ionization process. So this is primarily what responsible for the water breakdown of gases. So depending upon these things, so we can classify the ionization process, water ionization by collision, photoionization, and the secondary ionization processes. So this is for water. The either it may water the losing the electron, or it may what gain the electron by the water the collision process. So if the two atoms or two molecules or what joined together or attached together, so that is the process, that is the method, so is called as what? The electron attachment process. So in generally the ionization processes can be classified into four types. First one is ionization by collision, photoionization, secondary ionization process, and electron attachment process. So these three processes will be takes place what? With respect of what? The collision process, and this is what taken place in what? The attachment of the water electrons, or attachment or joining the atoms each other. Let us discuss type of ionization processes. Let me begin with the first ionization process, that is ionization by collision. In this process, ionization by collision, a free electron which collide with a water, the neutral gas molecule or atom, and which gives rise to a water new electron and a positive ion. So here I just consider the low pressure gas column in which the electric field is applied to plane parallel electrodes. So here two parallel electrodes are considered. So this is the one electrode that is called as what, a cathode. This is one more electrode. This is called as what, anode. So obviously, so the electric field is applied here. So due to this electric field, the electrons are ejected from the cathode. So the ejected electron, so it travels towards what, the anode. So during this travel, what happens? So here the insulating media is what? The gas itself is the insulating media here. So during this travel, this electron may collide with the water, the gas atom or gas molecule. So during this collision, so this there may be water, the liberation of water, the new electron and water, the positive ion. So the equation here shown, so this is water, the free electron which is moving in a water, the electric field. So this is what, atom. So this electron, it collide with an atom. So obviously in this case, so the potential what we consider, so this the energy which is gained during this travel between collision, which should water exceeds the water, the ionization potential. So in that case only there will be water liberation of water, the new electron and the one positive ion. So this is water, the liberation of an electron and the positive ion. So here you can observe where A is the atom, A plus is the positive ion. This is the A plus is the positive ion. So E minus is the water. This is water, one more electron. So this is the water, the ionization by collision process. Let us study one more ionization process, that is photoionization. Photoionization means ionization by influence by the radiation. The phenomena associated with ionization by radiation or photoionization involves the interaction of radiation with matter. So whenever the radiation of light which fall on the matter, atom or a molecule, so then the electron of an atom or a molecule which is liberated out due to what, the incident radiation. So this is called as what, the photoionization process. Photoionization occurs when the amount of radiation energy absorbed by an atom or molecule exceeds its ionization potential. You know, when the photoionization occurs, it occurs at when the amount of radiation which is absorbed by an atom or molecule which will exceeds the ionization potential. Ionization potential, it is nothing but each and every matter has its specific potential or the withstanding capacity of an potential voltage in which the matter, atom or a molecule, so which possesses the energy by the radiation. So this energy which exceeds the withstanding capacity of the energy which is already present in the water, matter, atom or a molecule. So then the photoionization occurs. Now there are several processes by which radiation can be absorbed by atoms or molecules. So what are the processes in which the radiation can be absorbed by an atom? So first process is excitation of the atom to a higher energy state. You know, the atoms or a molecules has the some specific the energy levels. So either the electrons will move or shift from one energy level to another energy level. So due to what, the incident radiation. So this is what one process, that is excitation of atom to a higher energy state. So atom will be excited what to a what higher energy state. Continuous absorption by direct excitation of atom or dissociation of a diatomic molecule or direct ionization, etc. That is continuously absorbing the radiation by direct excitation of atom. That is continuously atom can absorb the radiation. So that is called as what? Direct excitation of an atom. So these two are the methods in which the radiation can be absorbed by an atom or molecules. Just as an excited atom emits radiation when the electron returns to the lower state or to the ground state, the reverse process takes place when an atom absorbs radiation. So once the atom absorbs radiation, in that case the electron which will shift from one energy level to the another energy level. For an example, just as an excited atom, already excited atom which emits radiation, so when the electron return to the water lower state to the water ground state, lower state or to the ground state, that means one electron which return from higher state to the water lower state. In that case, the atom which the excited atom which emits the radiation. So if the reverse process will takes place, reverse process in the sense what, when the electron it shifts from lower state to the higher state. So in that case, the atom will absorbs the energy. So that is given by the equation. So this is the atom which absorbs the energy, that is h nu is the water, the nu is the water, the velocity of light. So h is the Planck's constant. So again it is associated with what, the energy the energy which is associated by water, your radiation. It is the radiation energy. So once the atom absorbs the radiation, so then atom will be in excited state. So the excited atom can be written as what, A star. So this is vice versa. So in this atom, it is initially, this is what, in normal position. Once it absorbs the radiation, in that case, so the electron of an atom which shifts from the lower state energy state into what, higher energy state. So in that case, the atom will be what, excited. So the reverse process means what? So once the electron which shifts from higher energy level to the what, lower energy level. So in that case, the atom will what atom will what, it emits the radiation. So once it emits the radiation water, so there will be a separation of water, the emitted radiation and the water atom. So this is what the reverse process will be what taken place here. Now the ionization occurs when the wavelength of light which should be less than or equal to Ch divided by Vi, where H is the Planck's constant, C is the velocity of light, Vi is the ionization potential, lambda be the what, the wavelength of light. Now you know the value of Planck's constant and value of velocity of light. Velocity of light value is what, 3 into 10 raised to 8 meter per second. Then Planck's constant value is 4.135 into 10 raised to minus 15 electron volt per second, or 6.626 into 10 raised to minus 34 joule second. If you substitute these values, that is Planck's constant value and velocity of light, so in that previous equation, in place of velocity of light c and the Planck's constant h, then you will get lambda which is less than or equal to 1.27 divided by Vi into 10 raised to minus 6 centimeter, where Vi is in electron volt. Now it is observed that experimentally that a radiation having a wavelength of 1250 angstrom is capable of causing photoionization of almost all gases. So if the ionization will be taken place for all the gases, so the radiation wavelength should be what it is, 1250 angstrom. It is observed by experimentally. So this is what the photoionization process. Let us study one more ionization process, that is secondary ionization process. You know, secondary ionization process, which is again influenced by ionization by collision and photoionization. You studied both ionization processes, that is ionization by collision and photoionization. So in both processes, so there will be a liberation of what? Electron. So during the ionization by collision and photoionization processes, whatever be the electron is liberated, from that liberated electron will further will makes an water ionization process. So that process is called as what? Secondary ionization process. They are briefly described below. So this ionization process, that is secondary ionization process, can be classified into three categories. First thing, electron emission due to positive ion impact, electron emission due to photons, electron emission due to metastable and neutral atoms. So now electron emission due to positive ion impact. The positive ions are formed by the water, the ionization by collision and photoionization. So due to this positive ion impact, so there will be a secondary electron is produced. So this is called as what? Electron emission due to positive ion impact. Then electron emission due to photons. Photons means what? It is a packets of what? Energy levels. So due to these photons, packets of energy levels, so there will be a emission of an electron. So that is called as what? Electron emission due to photons. Electron emission due to metastable and neutral atoms. You know what you mean by the metastable? Metastable atoms. Metastable atoms means what? The atom which lifespan is what? More than the what? The normal atom lifespan. So that is called as what? The metastable atom. So these metastable atom or neutral atom in the sense of what? The atom, it does not liberate an electron or it does not what? Gain an electron. So such type of atom, it is called as water. It is water electrically neutral atom. By these metastable and neutral atoms, there is a secondary electrons are liberated due to what? Collision, due to what? Ionization process. So this is called as what? Electron emission due to metastable and neutral atoms. Now let us study these one by one, how the secondary ionization process will be takes place by these three types of secondary ionization process. Now let us discuss electron emission due to positive ion impact. Positive ions are formed due to ionization by collision or by photoionization and being positively charged, and they travel towards what? Cathode. So that is here, the positive ions are formed. How the positive ions are formed? So positive ions are formed by the water ionization by collision and by photoionization processes. And being positively charged. So these are what? Positively charged. Positive ions are in the sense of what? Positively charged particles. And these positive ions, they travel towards the water cathode. A positive ion approaching a metallic cathode can cause emission of electrons from the cathode by giving up its kinetic energy on impact. So obviously, so whatever be the positive ions are formed by the ionization by collision or by photoionization processes, so this will approaching a metallic cathode can cause emission of electron from the cathode. by giving up its kinetic energy on impact. If the total energy of the positive ion, namely the sum of its kinetic energy and the ionization energy, is greater than twice the work function of the metal, then one electron will be ejected and a second electron will neutralize the atom. You know, so when this electron will be liberated, so there is a condition, in that case the electron will be liberated. What is that condition? The condition is that the total energy of the positive ion, so which is nothing but sum of its kinetic energy and the ionization energy. This is the what total energy of a positive ion, which should be what greater than the what work function of the metal. Work function of the metal in the sense of what, again, this is the water withstanding capacity of water, that particular metal. So whatever be the total energy of a positive ion, so it should exceed the twice of the water, the work function of the metal, the withstanding capacity of the metal. In that case, what happens? Then one electron will be ejected and the second electron will neutralize the ion. So there is an electron liberated by this process. So whatever be the electrons liberated by this process, the one electron so will neutralize the positive ion completely. Now here the electron will be what emitted out by the positive ion. So this is called as the electron emission due to positive ion impact. So since if the total energy of a positive ion, so which is greater than the twice the work function of the metal. You know the work function of the metal, it means water, the withstanding capability of the water metal in order to water ionize. So this energy of a positive ion, it is greater than the twice of the work function. So in that case, there will be electrons are liberated. So the second electron which will liberated by this process, so that will neutralize the water ion. So then now the probability of this process, which is measured by gamma I, so which is called as the Tausson's secondary ionization coefficients due to positive ion impact, and is defined as the not yield of electrons per incident positive ion. That is, whatever be the process will taken place, that is electron emission due to positive ion impact, so which is measured by what Tausson's secondary ionization coefficients, which is represented by gamma I, which is due to what the positive ion impact. Now there is one more secondary ionization process, that is electron emission due to photons. Uh, you know, this is one more secondary ionization process. So this is what influenced by what the photons. You know the photons. This is the again the packets of energy labels which cause to emit the electrons from the water, the metal surface. To cause an electron to escape from a metal, it should be given enough energy to overcome the surface potential barrier. So obviously, so once the electron will be escaped from the water metal surface, so we need to give the sufficient energy to the water metal, so in order to overcome the surface potential barrier. So once the provide energy which will exceeds the potential barrier, that metal surface potential barrier, so then the electron will be what? It is liberated from the what? Metal. Now the energy which is supplied in the form of a photon of ultraviolet light of a suitable frequency. Now what is the suitable frequency of that photon of ultraviolet light? So this is the condition. That is the electron emission from a metal surface occurs at h nu, which is greater than or is equals to the work function of the metal. You know h nu, it is nothing but what the frequency of the incident light or photon, that is ultraviolet light here. So this should be what greater than or equal to work function of a the metallic electrode. So then the electron will be liberated out from the metal surface of a metal or metallic electron. So here phi is the what? The work function, and again the frequency, that is nu, is given by the relation, that is phi by h. So this is called as what? The threshold frequency. Now for a clean nickel surface, so this is a metal nickel surface. So in that case, so that work function, so nickel surface metal work function is what? This is 4.5 electron volt. So this is the what? Work function. This is the phi. The threshold frequency will be the corresponding to a wavelength of what? 2755 angstrom. Just substitute the value here. The work function is about 4.5 electron volt, and with respect to this 4.5 electron volt, the threshold frequency will be the corresponding wavelength. So what is the threshold frequency for this corresponding wavelength? So you just substitute this value here, 4.5 electron volt divided by, you know, the Planck's constant. So Planck's constant, so that too in terms of electron volt, that is 4.135 into 10 raised to minus 15 electron volt. Then you will get the threshold frequency as about 2755 angstrom. If the incident radiation has a greater frequency than the threshold frequency, then the excess energy goes partly as the kinetic energy of the emitted electron and the partly to heat the surface of the electron. You know, if the incident radiation on the metal surface which has a greater frequency than the threshold frequency, in that case, so whatever be the excess energy, so that will goes partly to the water kinetic energy of the water emitted electron. So just consider a one metal surface. The radiation will be incident over the metal surface. So whatever be the incident radiation of a metal surface which exceeds or which is greater than the water, the threshold frequency. So in that case, whatever be the excess energy, so that excess energy, it goes to water the kinetic energy of the emitted electron. That is, whatever be the electrons are emitted from the metal surface due to incident radiation. So that emitted electron kinetic energy, so whatever be the excess energy will be formed here. So that will be added with the water the liberated electron excess energy, and some part of the energy, so that will be what? Heat the surface of the electron. Since work function, that is phi, is typically a few electron volts, the threshold frequency lies in the far ultraviolet region of the electromagnetic radiation spectrum. So in order to avoid this case, so we need to go for what? The phi, that is work function is typically what? Some few electron volts. The threshold frequency lies in the far ultraviolet region. You know the ultraviolet region, so that is nothing but what? Electromagnetic radiation spectrum. So this will be within the water, the electro radiation spectrum only. Now this is about water, electron emission due to water, the photons. What is the photon here? Photon of ultraviolet light with suitable frequency. So once the photon of ultraviolet light of suitable frequency incident on the water metal surface, so in that case, if this condition will be fulfilled, obviously metal surface has some work function. So whatever be the incident radiation or incident photon frequency, it is exceeded or is equals to the work function. So then the electron will be liberated out from the metallic surface. So now this nu, that is the frequency of the incident light or radiation. So this is given as phi divided by h. Phi is again work function, h is the Planck's constant. So this ratio is known as what? Threshold frequency. So if you consider one nickel surface metal, for nickel surface metal the work function is 4.5 electron volt. Now substitute the value of 4.5 electron volt and substitute the Planck's constant. This is the constant value. Then you will get the threshold frequency as a water 2755 angstrom. Now, if such an incident radiation of a threshold frequency of 2755 angstrom, so which fall on the metal, so in that case, what happens? The excess energy by the radiation, so that will be shared to the water, the kinetic energy of a electron, which is liberated by the water, the metal surface, and some part of energy will be utilized for heating the surface of a electrode. So since always we should go for what, the work function few electron volts. So in order to what maintain our that threshold frequency within the electromagnetic radiation spectrum. So this is about so one more process for secondary ionization process, that is electron emission due to photons. There is a one more secondary ionization process, that is electron emission due to metastable and neutral atoms. You know, a metastable atom or a molecule is an excited particle whose lifetime is very large compared to a lifetime of an ordinary particle. So ordinary, if you consider ordinary particle lifetime will be 10 raised to minus 8 second. So and this metastable atom lifetime will be, it is very large. This is what 10 raised to minus 3 second. Now then this metastable atom will influenced on the metal surface. So then the electron will be liberated. So that is, electrons can be ejected from the metal surface by the impact of excited atoms, provided that their total energy is sufficient to overcome the work function. So that is, so whatever be the excited atom, so this energy, it is sufficient to overcome the work function of the metal surface, then the electrons will be liberated from the metal surface. So this phenomena, this process is called as electron emission due to metastable or neutral atoms. This process is most easily observed with metastable atoms because the lifetime of other excited state is too short for them to reach the cathode and cause electron emission unless they originate very near to the cathode surface. So this can be what observed with the metastable atoms only, because metastable atoms, you know, the lifetime is very large. So if these lifetime will be very large, so then so we can easily move towards water cathode, or easily it reach to the water cathode. So then we'll liberate water electrons. So if you go for the water, the atom which has the less that short lifetime, so in that case, so the electrons will not be liberated. So once it move towards the cathode, so it will be what, vanish. So unless they originate very near to the cathode surface. So if it originate near to the cathode surface, so then only it happens that electrons will be liberated. But if you go for the metastable atom, so its lifetime will be more, since so it is easy to liberate electrons from the metal surface. Therefore, the yields can also be large, nearly 100%, for the interaction of excited helium atom with a clean surface of molybdenum, nickel or magnesium. So this is the helium atom is the water, the metastable atom which has the larger or very high lifetime, So this will be interacted on the surface of the molybdenum, nickel or magnesium metal. So then the electron will be liberated out from these metals. Neutral atoms is in the ground state also give rise to secondary electron emission if their kinetic energy is high. So that is equals to 1000 electron volt. At low energies, the yield is considerably less. So even you go for the water neutral atoms. So neutral atoms in the ground state. So that is the water lower energy level. So that can also water gives the water secondary electron emission. That means they can also liberate a secondary electron. So when they can liberate the secondary electron, if their kinetic energy is water, it is too high. So what is the kinetic energy? So it should be water. It is that is equals to 1000 electron volt. So then only so there will be electron will be liberated due to water the neutral atoms. So this is about what electron emission due to metastable as well as neutral atoms. There is one more ionization process that is electron attachment process. Electron attachment process, it is nothing but the attachment of an electron or a molecule to form a negative ions. So this is called as what the attachment process. So in that case also the electrons are liberated. So here the type of collision in which electrons may become attached or atoms or molecules to form negative ions are called attachment collisions. Now this electron attachment process, it depends on the energy of an electron and also it depends on the nature of the gas molecule or atom. And it is very important process from the engineering point of view. So that whatever be the electron attachment process, it mainly depends on the energy of an electron. This is the liberated electron. So whatever you studied earlier case. So if the energy of an electron will be lesser, so attachment process will easily taken place. And also it depends on the water, the nature of the gas. So if the gas property, it has a good property, so then only it is very helpful, it is very easy to water the electron attachment process. So an electron attachment process which is represented as, so here equation it is given here. So see, this is an electron, this is an atom, so this is an liberated electron and this is an ion. So this will be what these all are attached together. So if these all are attached together, then will form what the negative atomic ion, that is negative ion will be formed. And also with respect to what the the electron affinity means what this is the uh, what you can say, so this is the degree to which the substance tends to what combine with another. So what is the quantity or what is the what amount in order to what the combine the one atom with the another atom. So this is called as what the affinity. So this is represented as E suffix A, or you can say that electron affinity. And this is the what the kinetic energy, possessed kinetic energy. So this equation represents electron attachment process. So electron attachment process means what? The attachment of the water electron with the atom. See, this is an atom. So you just club combine with the with the water electron and the ion. So this respective ion. So then it forms a negative atomic ion. So with its kinetic energy as well as what the electron affinity. Electron affinity, it is nothing but it is a degree to which a substance or the atom or a molecule which tends to combine with another. So this is the equation. It represents the electron attachment process. In the attaching or insulating gases, the atoms or molecules have vacancies in their outermost shells and therefore have an affinity for electrons. So obviously in the attaching or insulating gases, you just consider the gases, insulating gases, the atoms or molecules have vacancies in their outermost shells. That means the outermost shells of an insulating gas atom or molecule. So these are what the blank. So there you cannot find what the electrons, and therefore have an affinity of for electrons. So whatever be the electrons will be what the combined with an atom. So those electrons will have what affinity. So those will what degree to what combine or degree to what. So the fulfill that particular what vacancies. The attachment process plays a very important role in the removal of free electrons from an ionized gas when arc interruption occurs in gas insulated switchgear. Now this attachment process, so it plays a very important role in the removal of free electrons from an ionized gas. So ionized gas in the sense of what? Arc interruption occurs in gas insulated switchgear. You know there is a switchgear device. In switchgear device, so there is an arc interruption process, because in switchgear you can find during the operation of an switchgear, so you can find the what the arc. So in order to interrupt this arc, so that is the arc interruption, so method will be what used. So in that arc interruption method, so you need to what the ionize the water gas. So this attachment process, it plays a very important role. So in arc interruption process of water, the switchgear. So this is the water, the electron attachment process. Now these all are water, the ionization process. Please go through with this ionization process. So if you find any difficulties, then you can free to ask anytime. So this is about the ionization process in gas. In next video, we'll come up with some more bits of this first module. Till then, take care. Bye.